Okay, so hi everyone. My name is Tashiana. I'm a tutor over at Seeds East, and this lesson is going to be on angles in geometry. So I'm actually going to switch over and share my screen. So hold on one second. Let's see. All right. Okay. All right. So, like I said, we're going to talk about angles in geometry, and this is coming from the packet. It's the contemporary packet in geometry, and it's pages 3 through 9, which is angles and angle relationships. So we're just going to get an idea of what angles are, and just kind of go through the lesson. So this works, right? So what we're going to talk about, first I want to introduce what angles are. We're going to look at how the angles are labeled because they're labeled a particular way. We'll look at how the angles are measured, the types of angles, and it will look at the relationships between angles. And throughout, we'll do some exercises to get a better idea of these concepts. Right. So first of all, what is an angle? So an angle is formed at the point where two straight lines meet. So looking at this image here, we have two straight lines and they're coming together at a point. And this point is called a vertex. So where those two lines meet, that's where the angle is formed. And we'll call these lines sides. An important concept to remember is that the wider apart that these sides are, the larger the angle is. So let me go through here. Okay. All right, let's keep going. So here's a few exercises just to get a better idea of how angles can look and determining which angle would be bigger. So in this first one, they want us to circle the largest angle in each group. So we have angle A, we have angle B, and we have angle C. One second.
Hello.
Hi, how are you?
I'm doing well. I'm so sorry about that.
No,
But
it's okay. It's kind of weird. I started recording it, so I guess you probably get edited out.
yeah, absolutely. We can here, do you wanna how do you want to do it? I mean, Chris can certainly chop this part out, or do you wanna stop and just
I can
start
start over
fresh?
because I had just started, so I can start over, I guess, if he wants, and it may be easier to
Okay,
edit.
that's fine. I didn't mean to like throw you off here.
So it's
When
okay. I
we're
was just like,
into it.
well, I don't know. I'll just wait 5 minutes and then start. So, so yes, so it's recording. So I'm just gonna go ahead and
Okay.
start it. All right. Okay, so I'm Tashiana, and today we'll be talking about angles in geometry just to get an idea of what they are and just learn some facts about them. And this is coming from the contemporary packet in geometry, pages 3 through 9, which are angles and angle relationships. So we are going to be talking about, one second. Okay, so we're going to talk about what angles are, how those angles are labeled, how we measure angles, the several types of angles that exist, and then we'll look at relationships between the angles. And of course, throughout, we'll do some exercises to get a better idea of those concepts. So first of all, what is an angle? So an angle is formed at the point where two straight lines meet. So here in this image, you see we got two straight lines coming together at a point, and we call this point the vertex. And that in between is an angle. And we call these lines sides. So when the two sides come together at that point, the angle is formed. And what's important to remember is that the wider apart the sides are, gives us an idea of how large the angle is. So if they're wider apart, the angle is pretty large. If it's more close together, the angle is small. So let me see here. Okay. So here's a few exercises to get a better idea of that. So the first one wants us to circle the largest angle in each group. So we have three angles in this group, angle A, angle B, and angle C. So we want to figure out which angle of the three is the largest. And we can tell that just by looking at them. So I'll give you a minute to kind of look at them and see which one you think is the largest. Okay. So the largest angle here is angle B. So what's important to look at here is how wide apart the sides are. So compared to angles A and C, these two sides are pretty wide apart, and that lets us know that this angle is larger. Then look at number 4 here, we have angle J, angle K, and angle L. So which angle between these three is the largest? I'll give you a minute. Okay, angle K. Once again, the sides are wider apart. That lets us know that that angle is larger. The next exercise wants us to circle the two angles in each group that are the same size. So here we have angle M, angle N, and angle O. Two of these angles are the same size. So looking at these, which ones do you think would be the same size? I'll give you a minute to look at them. Okay, so the two that are the same size are angle M and angle O. So what's important to remember, even though these may be flipped different ways, we see that the sides are different lengths, that angle is the same. So looking at number 6, we have angle P, angle Q, and angle R. So which two are the same size? Okay. So it'll be angles Q and R. So even once again, even though those sides are different lengths, those angles are the same. Okay, let's keep going. So labeling angles. So an important concept with angles, we have to label them a particular way. And there's 3 different ways that we'll label them. So the first way is using 3 letters. So you'll have angle and you'll have letters at 2 of these points and then 1 here. So this angle would be either angle A, B, C, or angle C, B, A. Both of those are correct, and you see it here. The important thing to remember here is that whatever letter or number is at the vertex, so at that point, it has to be your second letter. So it has to be in the middle. So no matter which way you go, you have to make sure that the vertex letter is in the middle. So that's why it's A, B, C or C, B, A. So the next one is we can name it by a single vertex letter. So it could be just a letter at the vertex. In this case, it'll be angle B, and that's just what that angle is called. Or it could be a number, and it may not be on the outside, it may be on the inside, but it's at the vertex, so that makes it angle 3. And this little symbol here that looks like a crooked L, that's how we symbolize an angle. So whenever you see that in front of, whether it's 3 letters, a single letter, or a number, that lets you know that we're talking about angles. So you have to remember, even if you're answering a question, you want to make sure that you put that symbol in front of the label. So now we're going to practice labeling angles a bit. So you can ignore that line there. But we have we have this angle here, and we need to figure out how we would label it. So there's 2 different ways. So I'll give you a minute to answer that. Okay. So it'll be angle, remembering that symbol, it'll be angle BCD or angle DCB. Just remembering that whatever letter is at that vertex, in this case is C, that's going to be my middle letter. How about this one here? So it'll be angle LMN or angle NML. Just remembering that M is my vertex, this is my point, so that's why it's my second letter. How about this one here? It'll be angle X. It's that single letter, but it's at the vertex. That lets us know that that's how it's labeled. And then the last one here, I know this angle looks a little different, which we'll talk about later, but how would we label this? It'll be angle 5. Here's my vertex, and there's the 5. Okay, let's move on. So measuring angles. So we measure angles using degrees, and we use the symbol. It's kind of the same. It's that degree symbol that you'll see a lot of times with temperature. But this is how we measure angles. And we think of these degrees as parts of a divided circle. So a circle, in terms of degrees, the whole circle is 360 degrees. So here's an example here to give us a better idea of that. So they tell us a whole pie is cut into 8 equal slices, and they want to know what angle do the sides of each slice make. So the first thing to note is that a whole pie, of course, is a circle, and they want us to find the number of degrees of each piece because we want to know what angle do these pieces make. So to find the number of degrees in each piece, we remembering that a whole circle is 360 degrees, I can take that 360 and divide it by the number of slices I have, which in this case is 8. So if I do 360 divided by 8, it gives me 45. So that's telling me that each piece, each of these 8 pieces, are cut at a 45-degree angle. And a way to check that, if I put 45 here and I added it 8 times, I should get 360. Okay, so I'm actually going to stop sharing my screen for a second. We're going to do a problem together. Okay, so let's see here. Hopefully you can see this. I have a whiteboard here. So the problem is saying that, and let me move that way. Okay, suppose you want to draw a circle graph that contains 6 equal sections, and they want to know first at what angle do the sides of each section meet, and then they want us to draw that angle. So here I already drew my circle, so I'm going to use a different color to draw those sections. So the first step in solving a problem like this is we want to look back at the problem and see how many sections they want us to cut it into. So as you can see here, it's 6. So I'm going to actually try to draw 6 equal sections in this circle. Okay, so I like to draw 6, like an X here, and then So of course I'm drawing it freehand, so it's not exactly equal, but there should be 6 equal slices here. So now they want to know what angle do the sides of these sections meet. So remembering that a circle is 360 degrees, I can take that 360 and divide it by how many sections or pieces I have. In this case, it's 6. So I'll do 360 divided by 6. That gives me 60, which lets me know, I'm just going to add my degree symbol because I don't want to forget that each of these pieces is 60 degrees. And a way to check yourself if you're doing exercises like this is that if I add 60 6 times, which is how many sections I have, or if I take 60 and multiply it by 6, I should get 360. Or whatever exercise you're doing, when you get that final answer and you add them all up, they should equal 360. If they don't, you want to go back and check your work. Okay? So that just gives an idea of how those angles are measured. So I'm going to share my screen again. Let's see here. Okay. So let's move on. So now we have several types of angles, and the type of angle depends on the degree of the angle. So the first one I will see is a right angle. So a right angle is L-shaped, and that it can look like an L, it could be flipped around, it could be upside down, but it's always that straight L shape. And usually if you see this small square in the corner, that lets you know that it's 90 degrees or a right angle. Right angles are always exactly 90 degrees. On the other end, you'll have what's called an acute angle. So this acute angle, as you can see, the sides are closer together. So they're less than 90 degrees. So it's not exactly that L, it's a little bit more closed in. So it's less than 90, but it's not completely closed. It's not completely flat. So it's more than 0 degrees. And one way I was always taught to remember it, and it's a little corny, but these angles, they're smaller and it's close together. So it's like a cute little angle. It's just the way to remember. But the closer together these sides are, and it's less than 90, that lets you know that you're dealing with an acute angle. Another type we have, though, is an obtuse angle. So this one, as you can see, the sides are wider apart, which lets us know, remembering back to the beginning, that the wider apart they are, the larger the angle is. So this one is going to be more than 90, so it's more open than that right angle, but it's going to be less than 180. And 180 degrees is actually our next angle, which is a straight angle. It's exactly 180 degrees, or thinking back to the circles, it's half a circle. If a circle is 360, and if you divided it by 2 or split it in half, you would get 180. So that's what a straight angle is. This obtuse angle is less than that, but it's going to be more than our right angle and definitely more than our acute angle. And then the last type is called a reflex angle. And this angle is kind of like one on a problem we saw earlier, where it's almost as if you're forming that whole circle, but not quite. So it's less than 360 degrees, but it's more than 180. So we went past that straight angle mark, but we're not quite at a full circle. Okay, so let's see. So now this exercise is just a matching exercise to try to see, just based on looking at different types of angles, if we can match them with its approximate size. So the first one we have here, it's on the outside here, and it's not a full circle, but what type of angle does that look like? And I can go back to our descriptions here. So that's a reflex angle. So what that lets us know is that it should be going back more than 180 degrees, but less than 360. So looking at our choices here, we have it could be number 1, won't be number 2, won't be 3, 4, won't be 5. So it could be 1 or 6. So looking at this, and I'm thinking of the circle, it looks like I'm pretty much almost there with the full circle, but I'm missing a piece. So I want to look for a number that's as close to 360 out of all of these. So in this case, that angle would be 270. It's a reflex angle. It's more than 180, but less than 360. And then since we have one more that is that reflex angle, I will look here at D. So as you can see, this one is also a reflex angle. It's more than 180, but it's not that full circle. So it's less than 360, and it's a little bit smaller than the angle in A. So that lets me know that D is 225 degrees. Looking at B, I see that this one, the sides are very close apart, which lets me know, very close together, excuse me, which lets me know that this angle is very small. So I'm going to look for, and it's smaller than the other angles here. So looking at these numbers, that lets me know that that's going to be 15 degrees. So it's not 0, but it's definitely less than 90. So it's an acute angle. It's 15 degrees. How about this one here? So we see that here's my vertex. I'm looking at those sides. They're pretty close together, not as close as B, but they're pretty close together. And I don't see, it's not that straight L shape. I don't see that square. So it's not a right angle. It's going to be an acute angle. And out of my choices, I see 45 degrees. So it's less than 90, but it's more than 0. But it's not quite as small as B. Then here we are at letter E. I see that these two sides are very wide apart, so that lets me know it's a large angle, but I'm not quite past 180, so it's not a reflex angle. So it's going to be less than 180, but it's not that L, so it's more than 90. So that lets me know that E is 125. And then the last one, I see out that straight L shape. I don't see that square, but that's okay. It's in this particular situation, so it's that straight L shape. It's less than 180. It's exactly 90 degrees. Okay. So this just shows us that we can look at angles and just knowing the types of angles and how they will look, what their degrees could be, that can help us determine what type of angle and some approximations of what their size could be. So let's move on. So now we're going to look at the relationships between angles. So angles can be added together to make a single larger angle. So the first type are called complementary angles. And these are two angles that add together to get 90 degrees. So looking at this image here, I have angle QRT and I have angle TRS. And just remembering back on how we label them, R is that vertex, so that's why it's the middle letter. But what this is saying is that angle QRT, if I take that angle and I add it to angle TRS, it forms a larger angle, which in this case is a 90-degree angle. That L shape, y'all see that square? So when I add those together, they equal 90 degrees. This tells me that those two angles are complementary and that they're complements of each other. So angle QRT is a complement of TRS and vice versa. The other type of relationship is a supplementary angle, and these two angles add together to get 180 degrees. So as you can see, I have angle LMO and angle OMN. And when I add those two together, they make a straight angle. As you can see, it looks like half a circle, and it gives me 180 degrees. This lets me know that these two angles are supplementary and that angle LMO is a supplement of angle OMN and vice versa. So this slide is just going to tell us a way to solve problems that may exist when they're asking about the relationships between the angles. So the example here, it tells us, as shown at right, angle ABC is a right angle, 90 degrees. What is angle ABD if angle DBC is 52 degrees? So the first step when you're coming across a problem like this is you want to figure out, is the larger angle that the two form, is it a right angle or a straight angle? So looking at this one, and even in a problem, they actually tell us that it's a right angle. It's 90 degrees. That's what the two form together to make. So knowing that, I can take the angle that they gave me, which was 52 degrees. If I subtract it from my larger angle, 90 degrees, I'll get my answer, which in this case is 38 degrees. So what that's telling me is that angle ABD is 38 degrees. And if I took that away to check your answer, if you add 52 and 38, you should get 90. So let's see here. So here's two examples. Let's go through these together. So I have two angles here. I have angle RST and angle TSU. And they want us to figure out what angle RST is. So remember, I'll walk you through this first one, then I'll give you a chance to do the second one. The first step is figuring out, what is my larger angle? Is it a right angle or is it a straight angle? So this one is a straight angle. So that tells me that the two angles should add together to get 180 degrees. So my second step, I would do 180 minus the angle they gave me, which is 64. And in doing that, that'll give me what that angle RST is, which is 116 degrees. And the way I would check that is I would add 116 plus 64, which should give me 180. If for some reason you do that and you don't get it, just go back and check your work. So now let's look at number 9 here. They want to know what angle HGI is, and they gave us angle FGH. So I'll give you a minute to work through that. So as we can see here, the first step, what is my larger angle? I see that, okay, I have that L shape and I have that square. That lets me know that the larger angle is a right angle, so 90 degrees. So then my next step would be to subtract the angle they gave me, which is 40 degrees, from 90 to get the answer of what the angle HGI is, which is 50 degrees. Okay, so I'm going to stop sharing my screen again for a second because I have another problem, and this one is a word problem. I'm going to try my best to hold it up again. Okay, so, and excuse my drawing skills, I try to draw the best I can, but there's two pieces of irrigation pipe that are joined as shown below. What is the value of the acute angle formed by the connected pipes? So as you can see here, and I'll kind of bring it a little closer, and hopefully you can see, there we go. Okay, I have this pipe here, and they gave me one angle. They gave me 127. And they want to know what the acute angle is that's formed by the connected pipe. So I'm going to use this marker to show, if this is 127, they want to know what this angle is here. That's my acute angle. So I'm going to kind of redraw this in a way that's like the problems we've been doing. So I have a straight line and I have a line going there. And this one they're telling me is 127. And they want to know what that acute angle is, that angle inside. So knowing that first, using our steps, I'll let you work through it. But we see that, okay, what is the larger angle? Is it a right angle? Is it 90 degrees? Is it a straight angle? Is it 180? And looking at that, you can see that it's 180 degrees because I have my straight line here. So I would do 180 minus the angle they gave me, which is 127. So now I'll work it out here, up here. So I'll subtract those. That gives me 53. So that means that this angle here is 53 degrees. And if I add those two together, I should get 180. So this is just a problem that kind of gives us some real life application on how the relationship works between angles. So I'll kind of leave it up a minute so you can look at it. But you can see that even though we have these shapes, we actually have this structure, which is a pipe, we can kind of visualize how it would look if it was just straight lines. Okay. All right, so I'm going to share my screen again. All right. So we're almost there. Oops. Okay. So the next section is angles that are formed by intersecting lines. So we have lines that are crossing each other. We are forming vertical angles. So vertical angles are angles that are opposite each other when those two lines cross. And it's important to remember that vertical angles are equal to each other. So looking at this image here, we have two lines that are crossing, almost like an X. Well, it is an X. And we have angle 1, angle 2, angle 3, and angle 4. So what vertical angles are angles that are opposite each other, like 2 and 4 and 1 and 3. The angles that are opposite each other are equal to each other. So that means angle 1 is equal to angle 3. Angle 2 is a different angle, but it's equal to whichever angle is opposite it. So angle 2 is equal to angle 4 because they are vertical angles. So here's a quick exercise to find a value of each angle here. So I have two lines that are crossing, which lets me know, okay, I'm forming vertical angles. And looking at this, they gave me 30 degrees and they gave me angle A. And they want to know, what is angle A? So looking at these, I see that they're opposite each other, which lets me know that they're equal. So angle A is 30 degrees. Looking at number 2 here, I have two crossing lines again. It may look a little different, but they still cross. And I have this obtuse angle, which is 134 degrees. And they want to know, what is angle X? So even though it's shaped a little differently, these angles are still opposite each other, which lets me know that they're equal. So angle X is 134 degrees. Okay, so let's go on. Okay, sorry about that. So then our final concept are parallel and perpendicular lines. So I'm actually going to zoom in here a bit so you can see. They'll let me do it. Okay, there we go. All right, there we go. So parallel lines are those that never cross and they run side by side. So in this case, line C, which goes across here, and line D, which goes across here, they're parallel. So they're running side by side, but they'll never cross. And this symbol here, which actually looks like two parallel lines, that's the symbol for parallel lines. So whenever you see this, that lets you know that line C is parallel to line D. Okay, so that's another symbol to remember. When we add a line that cuts through them, we call that line a transversal, and it cuts those two parallel lines. But what that transversal does is it forms angles, vertical angles that we just talked about between the two lines. So looking at, let's start with A, angle A. Now remember, vertical angles that are opposite each other, they're equal. So that means that angle A is equal to angle C. Whatever that number would be, they're going to be equal. Same with angle B and angle D. It's going to be a different number than A and C, but they're going to be equal between each other. Same with, if I look down here, angle E and angle G are opposite each other, so they're equal. And angle F and angle H are opposite each other, and they're equal. So one thing, what this is showing down here is that because these are parallel lines, and only because they're parallel lines, angle B and angle D, that whatever that number is going to be the same as angle F and angle H. Same with angle A and angle C, so they're equal because they're vertical angles, but they're going to be equal to whatever angle E and angle G are because of these parallel lines. So I'm going to kind of zoom back out. Uh-oh. Hopefully it lets me. Okay, there we go. So, and this is just everything I said in word form. So when two parallel lines are cut by a transversal, the four acute angles are equal. So angle B, angle D, angle F, angle H, they're equal. And the four obtuse angles are equal. So angle A, angle C, angle E, and angle G. And then each of the acute angles are supplementary to each obtuse angle. So just zooming again, I know I'm saying angle a lot, but angles A and angle B here, as you can see, thinking back to those relationships we just talked about, they form a straight angle if I add them together. So that means that whatever angle A is plus angle B should equal 180, and that's what that's showing here. Same as if I looked at it sideways, this is still a straight angle that's formed. So angle A and angle D will equal 180 too. And we're going to do some problems and exercises to kind of understand this a little bit more, but that's the general idea. And then, so that's parallel lines. So then perpendicular lines, if we have two lines that are crossing, so they're not parallel anymore, they cross, and let me zoom in again. Okay. They form right angles. So they're always going to be right angles. We see that they're straight L shapes, right? Even though we don't see that little square right now, whenever they cross, almost like a cross or an X, it's going to be perpendicular. And this is the symbol that we use to show perpendicular lines. So this is telling me that line A is perpendicular to line B. So that means that the two lines cross and form right angles. And just looking at that, that means angle A is equal to angle B, which is equal to angle C, and equal to angle D. So they're all 90 degrees. Okay, so let me come out of this. And then let's do some problems. I'm actually going to switch back to my whiteboards because I like using them. Hold on one second. All right. So I gave you two examples of parallel lines problems. Okay, I'm going to use my red marker again. Looking at the first one, what this is saying is that line A, which is here, is parallel to line B, which is here. And those two lines are going across. Knowing that, they want to know what angle 1, angle 2, and angle 3 are. And they gave us one angle that's 106 degrees. I hope that, I know it kind of wrote small, so hopefully you can see that. So line A is parallel to line B. And they want us to know what angle 1, angle 2, and angle 3 are. And we can figure out what those are with that one angle that they gave us, which is 106 degrees. So let's try to figure out what angle 1 is first. So here I have, okay, so I know that these are forming, I have 106 degrees. And if I remember correctly, vertical angles let me know that the angles opposite each other are equal. So that means the angle 1 is equal to angle 3. But also, if I was to number the rest of the angles, let's say I call this angle 4, angle 5, angle 6, angle 7, and then angle 8 is 106 degrees. That lets me know that angle 1, remembering back to our notes, angle 1 and angle 3 are equal, which are equal to angle 5 and angle 8. So I know angle 8, which is 106 degrees. So that lets me know that angle 1, which is also obtuse, by the way, is 106 degrees. So based off of our rules of vertical angles and the relationships when we have parallel lines, I can figure out what number 1 is. So then also, because angle 1 and angle 3 are vertical angles, that means they're equal to each other. So I automatically know angle 3 is also 106 degrees. So now angle 2, I'm going to use my rule about the relationships. So I see here angle 1 and angle 2, they are connected and they form a larger angle, which is that straight angle, which is 180 degrees. They're supplementary angles. That's their relationship. So that means angle 1 plus angle 2 should give me 180 degrees. So if I add, sorry, I'm trying to make this as clear and also right. Angle 1 plus angle 2, which gives me 180. I already know what angle 1 is. Remember in our steps on how to solve the relationships, I would subtract the angle that they gave me, which in this case we figured it out is 106, from that larger angle, which is 180. So I would do 180 minus 106. And then I'm just going to solve it here. Minus 106. That's going to give me, oh, did I right? Yeah. Okay, so it gives me 74, excuse me, 74 degrees. So that lets me know angle 2 is 74 degrees. And a way to check that is that you would do 106 plus 74, and it should give you 180. Okay. So we were able to figure out what those three angles are from the one angle that they gave us, which was 106, just based on our relationships between angles and vertical angles and knowing what happens when angles cross. Okay. So look at this next one. I'm actually going to use a different color so we can tell them apart. I have, okay, lines O and lines P. So this time they're not going across, they're going up and down, they're going vertical. So here's line O, that's line P. They want us to know from those, and that they're parallel to each other. They tell us that. Remember that symbol, the two lines? So O and P are parallel. And they want to know what is angle X, angle Y, and angle Z based off of those two lines. So the lines are parallel, and they have this transversal that cuts through. And that transversal cutting through, they gave me one angle, which is 60 degrees. So knowing that, I can figure out what X, Y, and Z are. So these angles, X and Z are vertical. They're opposite each other. So I know whenever I solve it, angle X is going to be equal to angle Z because they're opposite angles. Okay. Angle Y, if I was to number these again, and I can kind of flip it so it looks like the other one, it'll give me 1, 2, 3, 4, 5, 6, 7, and 8. So I know angles 1 and 4, or in this case, 1 and Y are equal. And so is, and those two are also equal to angle 5, which we don't know, and angle 8, which we do know, which is the 60 degrees. So that lets me know that angle Y is equal to 60 degrees. Sorry, there we go. So knowing that, I can figure out what X and Z are because of these relationships. I'm actually going to erase a little bit of this because I don't want to confuse anybody. Okay. So now I know that y is 60 degrees. And if you look at this, x and y, remember in our relationships, x and y are supplementary. So that means the larger angle they form is 180. So I can do 180 minus the angle that they gave me, which I figured out, which was 60. And that'll give me what angle x is. So 180 minus 60 is 120 degrees. I keep going the wrong way, sorry. So x is 120 degrees. Now remember, we figured out earlier that x and z are vertical angles. That means they're equal. So if x is 120, then z is also 120 degrees. So that just gives us an idea of how to use those relationships to figure out what angles are, especially when it comes to parallel lines. So I'm going to share my screen one more time. And we're almost there because we've pretty much been through it. So let's see. All right. So I'm just going to sum things up. So key things to remember is that we measure angles using degrees, and we think of circles as our way of how to determine what the degrees are. There's 5 types of angles, which are right angles, acute angles, obtuse, straight, and reflex angles. Complementary angles and supplementary angles are formed by a relationship between those angles. So that means they're 2 angles that add together to get either a right angle at 90 degrees or a straight angle at 180 degrees. Then we have vertical angles when 2 lines cross and then they form angles, and those angles are opposite each other and they're equal to each other. And then vertical angles we'll see also when we bring in lines. So we bring in parallel lines, which are those that run side by side and they never cross each other. They can give us relationships between angles as well. And then perpendicular lines are those that just cross, almost in that cross formation, and they always form right angles in 90 degrees. So this lesson was just to give you an introduction to angles. Angles are important to know and to remember, because as you go further on into geometry topics, having an understanding of what angles are could help you with those future concepts that'll come up. So hopefully this was helpful. If you have any questions, of course, you can feel free to reach out. And thanks for listening, and enjoy your evening.